Hey, so I did a first recording of this. This is my second recording, so I'm just gonna like redo this. Yeah. Hold on, I gotta pull up MS Paint again. I recorded this and I did it all wrong. Okay, so I open up MS Paint. So I'm gonna show you how binary works. So binary, ones and zeros. Binary number, real quick. This is a binary number. Right there. Look, binary. That's a binary number. Let's move it down here. So that's a binary number right there. And basically the reason why we use binary numbers is because computers can't think in normal human numbers. So like a normal human number would be like 13, right? So 13 is a normal human number, but computers can't think in normal human numbers. A computer can't read the number 13. A computer has to use binary to do it. Computers work in ones and zeros, and so if you want to tell a computer 13, you have to convert it into binary first. Things like Python and MIT App Inventor automatically convert it into binary, basically. All of the things that you write code in convert all of the code that you've written, they convert that into binary to tell the computer because computers don't speak anything but binary. And we use programs to help make binary easier for humans by making things like Python and Java and MIT App Inventor and so forth. So, how do you convert it? Basically, you can make any number using binary, and this is how. So, each number represents a slot, basically. Like, it can be on or off. 1 is on, and 0 is off. So, this one is on, or, hold on. Yeah, each number represents a slot. It can be on or off. So, each one represents a different number, and it doubles in its value. So, the first one is number 1. This is number 2. This is number. Did I really just put number? No, I didn't put number 3 down. Don't judge me. This is number 2. This one's fuck. This one's number 4. Then you double 4, you get 8. This one's 16. This one's 32. This one's 64, and this one is 128. Um, so pretty much these are the numbers of binary basically, and this is pretty much how you create all of the different numbers out of these. So these are how all the different ones are represented. And if it's 1 or 0, basically it means whether it's on or off. So I'm going to use red and green to determine whether they're on or off. So if it's a 1, it's on. These ones are on. Number 8, that's a 0, so that one's off. Shit. That one's off. 16 is off. 32 is on. 64 is off. And 128 is off. So you don't need to think of it like zeros and ones. You can think of it like on or off. So basically, their ones and zeros are essentially just switches. It's 1 is on, 2 is on, 4 is on, 8 and 16 are off, 32 is on, 64 is off, and 128 is on. So here's how you get actual numbers out of it. So let's say that you have this number and you want to convert it. You're like, good, I know what all the numbers are. I know that it's on and off. How do I convert it? So 1 is on. That means we basically take this and we add up all of the numbers that are on. So 1 is on. We do 1 plus 2 is on plus 4 is on. 8 is not on, so we don't do 8. We don't do 16. Oh, shit. 32 is on, so we add 32. 64 is off. 128 is on, so we add 128. And if you do some quick maths in the calculator, you get, hold on just a second. I don't want to type this out, and I'm just buying time because I can't do math. Uh, 130. If you add them all up in a calculator, which you will not be provided on the exam, and you should be able to do quick maths, but 32 and 128 is 160. 167 is the number. So basically, 167 is your number. Add them all up like a gamer boss. Did I get it right? Let's see. Plus 32 plus 4 plus 2 plus 1. Hey, let's go. 167. So that's basically how you do it. So this might be a little overwhelming, and this has been about 5 minutes. So I'm going to go ahead and give you an example of how to do of another example of how to do this. So that is our first example. We'll go ahead and stretch this out. Yoink. Ah, what the fuck? There we go. Stretch it. Okay, so let's go ahead and scroll over here. And let's go ahead and do another example of what a binary number would be. So let's say we have 0, 1, 1, 1, 0, 0, 0, 1. Alright, let's just do that. So they could give you any amount of numbers, but the length of the numbers is important because that's how far you go. And you can't just look at the end, like how normally, like if you like took the number like 68, you took the number 68, you look at the end, you say, oh, there's an 8 at the end, so it's 8 plus 6. That's 8 plus 60. That's 68. You can't do that in binary. Binary goes the other way. You can't look at the end and say, oh, this is a 1. No, you have to start at the beginning. You have to start over here. So, let's go ahead and solve this binary real quick. Hold on. So, don't feel bad if you have to do this every time that you write out the binary. You can absolutely still pass the exam and score very well on it if you can't do the binary in your head. It's pretty simple and easy to write it out. You just start at the beginning. What number do the numbers start with? Number 1. What's 1 times 2? 2. 2 times 2? 4. 4 times 2? 8. 8 times 2? 16. 16 times 2? 32. And the numbers keep going up, and it's a good idea to kind of familiarize yourself with how computers think. They go like 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, whatever. They keep going up. You don't really need to know that stuff, but if one day you have to solve a thing of binary that's like this many things long, that's a lot of numbers. So it makes it easier if you kind of memorize, like, oh, 1, 2, 3, 4, 5, 6 numbers in, that's 32. And if I go 8 numbers in, like over here, it ends in 128. So just like little things to know. But you don't really need to know any of that. Again, look at this problem. Boom, 1, 2, 4, 8, 16, 32. Just write that above each number, and then let's go ahead and solve it. So 1 off. We don't use the 1. I'm going to visualize it. 1 off. 2 on. 4 on. 8 on. 16 off. 32 on. What did we get? 2 plus 4 plus 8 plus 32. 8 plus 32 equals 14. Wait, no. 46. 46. I knew that. It didn't take me like 30 seconds to solve a stupid math problem. I'm good at math, trust me. Okay. So, yeah, that's how you solve the problems really quickly. So let's go ahead and try another one. Again, they're pretty quick. If you get the hang of just going, writing all the numbers down, seeing which one's on and off, let me go ahead and give you a longer one to do. 1, 1, 1, 0, 1, 0, 1, 1, 1, 0. That's more binary. So, real quick, you're on your AP exam, you're sitting there in Cornerstone, you're stressed as all heck, and you're like, oh god, I don't know what to freaking do for this stuff. Oh, let's, 1, 2, 4, what's 4 times 2? 8, 16, 32, 64, 128, Oh God, I'm running out of time on these. Oh God, okay, okay. One's good. No, yes, no, yes, yes, yes. No. One plus 4 plus 16 plus 32 plus 64, and then that is those quick maths. 80 plus 32, that is 112 plus 5, 117 plus 4 plus 16 plus 32 plus 64. Yeah, 117 answer. Um so yeah, that is basically the quick and simple version of how binary works. Uh, that's how you solve it, and that's how you think of it. This is the best that I can do for now. I'm so sorry. But stick around in the video if you want me to talk about the oh Jesus Christ! I swear to God, I forgot about that. Stick around in the video more if you want me to talk about if you want stick around in the video if you would like me to talk about some tips and tricks for solving binary quickly. Tips and tricks that I like to use for doing that. Okay, so tips and tricks for binary. How long are we? 11 minutes in? Okay, that's okay. Um, so yeah, tips and tricks for binary 101. Um, so let's see. Um, hold on, I gotta check my phone to be sure it's nothing. Hold on. Kyla, I'm making this video for you, just so you know. There we go. Okay. Send message. Okay. So, what was I saying again? Oh yeah, tips and tricks to learn binary. So, let's say that we got 1111111. I work a lot with computers, as you may already know. And so I know a lot of these numbers just because literally this is what like all computer parts, resolutions, file sizes, every single thing are based off of these numbers, and it's for a pretty good reason. File architectures, like literally like anything in computing, the numbers are probably powers of 2. So let's go ahead and take a look at these numbers and let's see what's up. So, um, here's some numbers to remember. 1, 2, 4, 8, 16. Oh god. Okay, you know what? I'm just gonna freaking 32, 64, 128, 256. Fuck. Oh, Jesus Christ. Okay, this is turning out really terribly. I'm just gonna get rid of all this. Okay, I'm just gonna type it in like smaller text. Okay. So now we've got 1, 2, 4, no, not 5, 8, 16, 32, 64, 128, 256, 10, 24, 20, 48. That's not 48. That's not 48. 40, 96. What is the 9? Oh my Jesus. It's something. I know it. I know what it is. Dingus Pingus. Okay, I don't think I knew that. 8192, and then that is another number. Okay, these numbers are big. You're probably not going to use the big ones. 8192 times 2. Okay, yeah. Yeah, you don't really need to know anything past this. Yeah. If I don't know it, then you definitely don't need to know it. So, yeah, we're just gonna forget I said that. We're gonna take all these guys, send them to the Shadow Realm. Bye. Okay, so yeah, these are some useful numbers to know. You know the game 2048? It's like that. That game's actually very much like binary, which is pretty cool. Um, but yeah, so these are the numbers to know. And here's a cool thing. So if you have, let's say that you have all ones, right? Let's say that you have all ones, 72.111111. So if you have these numbers right here, let's line them up. So if you have these numbers right here, right? You see how this kind of cuts off right there? So this goes up to 64. If you have a binary sequence that has this many values and the final value of it is 64, then all of these values together, I'm going to do some quick math here. 4a plus 16 plus whatever. I already know the answer. It's 127. Boom. How did I get that answer? Because I'm a freaking genius. Not really. It's actually very easy. I don't know if you noticed, but what's 127 less than? It's 1 less than 128. Hold on. You might see a pattern emerging. If I do the same thing, and then I do the exact same thing, and I do 1, 1, 1, 1, 1, 1, 1, 1, 1. How quickly can I do this math? Let's see. It cuts off at like right here, right? How quickly can I do this math? I know what this binary sequence is. You know why? I know exactly what this is. This is 1023. Boom, quick maths. I know that because it ends right there. And here's a cool thing that you can do. What if your number is this? Hold on. Epic. What if your number is this? 0, 1, 1, 0, 1, 1, 1, 1. Okay, what if your number is this, right? And you see here, it ends at 256. But which numbers are missing? You have your 1 and your 8. So if you know that all this stuff is 255, right? You know that this is 255. What's missing? The 1 and the 8. 255 minus 9 is 246. And boom. Let's go into the calculator. If this isn't right, I'm going to shoot myself. 2 plus 4 plus 16 plus 32 plus 64 plus 128. Boom. Epic. So yeah, basically this is a little trick. If you take however many numbers you have, go one further. This ends at 128. So go up one more and then subtract the ones that are missing. This is really only useful when you have more ones than zeros, and usually it's pretty 50-50 split. Statistically speaking, they're going to give you about as many ones as they do zeros. So this is just a neat little trick to remember it. Yeah, that doesn't really touch a lot on the theory of binary, but as far as stuff goes, you just need to learn how to convert it. And yeah, this is how computers think. And yeah, it's pretty cool. You know how like 64-bit architecture on your computer? I don't know if you know what that is. Boom, 64-bit, 32-bit. What? That's so crazy. And also, how many colors are there in Paint? What is white? 255, huh? Guess how many values you can have? You can have 256 values because you go from 0 to 255. And binary starts at 1, so the 0 is an extra value. So this right here, your red value, is actually just 1, 0, 1s, 1s, and zeros. What? Computers are made of this stuff. Yeah, but that's how you do it. Is this video that long? 19 minutes. Okay. Have fun. Hope you learned something.